Hello everyone, welcome back to a new video. We have practice 5C. Question 1, it says what? Question 1. If the image of a crayon appears to be 23 centimeters behind the surface of a convex mirror, we have the image distance, which is equal to 23 centimeters. Okay, but don't forget, this is minus. Why? Because it's a convex mirror. And is 1.7 centimeters tall. So h prime, which is the image height, is going to be equal to what? 1.7 centimeters. If the mirror has a focal length of 46 centimeters, so focal length is equal to 46 centimeters. How far in front of the mirror is the crayon positioned? So P is equal to what? Which is the object distance. What is the magnification of the image? Magnification is equal to what? Is the image virtual or real? Because it's a convex mirror, so the image is of course going to be virtual. Is it upright or inverted? It's going to be upright. How tall is the actual crayon? So h, which is the object height, is equal to what? Now let's start. Question 1. Remember, when we are trying to find p, the object distance, we had this equation: 1 over p plus 1 over q is equal to 1 over focal length. I think, yeah, don't forget we have minus here, minus 46. Why do we put minus? Because it is a convex mirror. Focal length and object distance, image distance, are going to be negative for convex mirrors, but for concave mirrors, they're going to be positive. Now we have 1 over p. P is equal to what? We don't have it. Then take this one to the other side. We're trying to find this one. So 1 over p is equal to 1 over f minus 1 over q. Do we have focal length? Yes, we have. Focal length is equal to minus 46. So minus 46. Then we have minus here. Q is equal to what? Which is the image distance, is equal to minus 23. Okay. Then 1 over p is going to be equal to what? It is going to be equal to, if you divide this, divide 1 by minus 46, you're going to get minus 0.0217. Then you have this one, okay, let's put that in a bracket, minus 1 divided by minus 23, you're going to get minus 0.0434, okay. Then if you calculate this, you're going to get 1 over p, which is going to be equal to 0.0217. Okay, cross multiplicate. This is basically plus, minus with minus, you're going to get positive. Then just add them and you're going to get 0.0217. Then cross multiplicate. You have 0.0217p, which is equal to 1. Divide this by 0.0217. Divide the other side by 0.0217. Cancels. P is equal to what? It is equal to 46 centimeters. This is the position of the object. What about the magnification? Okay, magnification is going to be what? Magnification in terms of the distance is going to be minus q divided by p. Do we have q? Yes, we had. It was equal to minus 23. Okay, then divide by what? Divided by 46. Okay, 46 was what? Was the image object distance, which we just found. Now this is magnification is going to be equal to what? It is going to be 0.5. Remember, magnification is always less than 1 for convex mirrors. Did we get my 0.5? Yes. Did you get less than 1? Yeah. 0.5 is less than 1. Now what about the height? How do we find the height? Height of the object is equal to what? We found magnification, so it's going to be pretty easy. So magnification is going to be equal to what? Image distance, image height divided by object height. We're trying to find this. So height is going to be equal to what? It is going to be equal to h prime divided by magnification. H prime is equal to what? It is equal to 1.7. Magnification is equal to 0.5. Then the height of the object is equal to 3.4 centimeters. That is the height of the object. This is question 1. Let's move on to question 2. But just let me erase that. Let's move on to question 2. We have a convex mirror again with a focal length of 0.25 meters. So focal length is equal to 0.25 meters. Don't forget the minus. Minus 0.25 meters. Why minus? Because it's a convex mirror. Focal length for convex mirrors is always negative. Forms a 0.08 meter tall image of an automobile at a distance of 0.24 meters behind the mirror. Now we have what? We have the height of the object, of the image, which is equal to 0.08 meters. And then what about the distance of the image is equal to 0.24 meters. So Q is going to be what? It is going to be minus 0.24 meters. Why minus? Because it's a convex mirror. Then it says, what is the magnification of the image? Magnification is equal to what? Where is the car located and what is its height? Height of the car is equal to what again? Is the image real or virtual? Is the image upright or inverted? So it's a convex mirror. Of course, it's going to be inverted and virtual. Now let's begin. Let's first find the distance of the object, and then we're going to find magnification. It's the same question as question 1, just the numbers are different. 1 over P plus 1 over Q is equal to 1 over F. I'm trying to find P here. So 1 over P is going to be equal to what? 1 over F minus 1 over Q. Then this is going to be what? 1 over P. F is equal to what? It is equal to minus 0.25. Then minus 1 over Q is equal to what? It is equal to minus 0.24. Okay. Now, if you divide this, you're going to get minus 4 plus 4.16, like 4.1616. Okay, then if you subtract this, or if you add these together, you're going to get 1 over P, which is equal to 0. Of course, this is going to get a positive result, 0.1666. Then cross multiplicate. 0.1666 P is going to be equal to 1. Divide this by this number. Divide the other side by the same number. 1666 cancels. P is equal to what? It is equal to 6 meters. Careful, okay? Because we had the numbers in meters. We are not dealing with centimeters here. That is the object distance. Let's find magnification. Magnification is equal to what in terms of distance? If you ask, why do we use the magnification in terms of distance? Because I first need to find the magnification, then I can use the magnification to find the height of the object. Okay, so magnification in terms of distance is equal to minus Q divided by P. Then this is going to be what? This is going to be minus 0.24, which is the image distance, divided by 6, which is the object distance. Magnification is going to be what? It's going to be equal to 0.04. You see it's less than 1, so it is virtual and upright. It's a convex mirror. Magnification in terms of height is going to be h prime divided by h. Do we have h? Yes, it was equal to 0.08 meters. So h, which is the object height, is going to be image height of 0.08 divided by magnification, which is equal to 0.04. Then height is equal to what? Is equal to 2 meters. That is the height of the object. Question 3. A convex mirror again of focal length 33 centimeters forms an image of soda bottle at a distance of 19 centimeters behind the mirror. First of all, we have the focal length. Focal length is equal to what? It is equal to minus 33 centimeters. Then we have what? We have the distance of the image, which is equal to minus 19 centimeters. If the height of the image is 7 centimeters, so h prime is equal to 7 centimeters, where is the object located? So P is equal to what? How tall is the object? H is equal to what? What is the magnification of the object? Magnification is equal to what? Let's begin. It's the same question. We have the same unknowns. So we have what? Again, we have 1 over P, which is equal to 1 over F minus 1 over Q. Okay? 1 over P is going to be what? Is going to be equal to 1 over F, which is minus 33, minus 1 over Q, which is equal to minus 19. And then if you divide these, you're going to get minus 0.0303 minus, this is in a bracket. Then you have, if you divide this, 1 divided by minus 15, you're going to get minus 0.0526. Okay, 1 over P is going to be equal to what? Is going to be equal to 0. If you just basically add these two together, 0.0223. Again, cross multiplicate. 0.0223 P is going to be equal to 1. Divide this by 0.223, and then divide the other side by 0.0223. Cancels. P is equal to what? It is equal to 45 centimeters. That is the position of the object. Okay, that is the distance of the object. Now, magnification is equal to what? It is equal to minus Q divided by P. Do we have Q? Yes, we had Q. Q was equal to minus 19. Okay, don't forget to put minus, convex mirrors. Okay, then divided by the object distance, which is equal to 45. Magnification is equal to what? It is equal to 0.41. Okay, that is the magnification. Use that magnification to find height. We had h prime. Okay, h prime was equal to what? Was equal to 7. Rearrange the equation. Height is equal to what? It is equal to 7 divided by 0.41. This is equal to what? This is equal to 17 centimeters. That is the height of the object. Then we have question 4. A convex mirror, again, with a radius, but this question is different. A convex mirror with a radius of what? With a radius of curvature of 0.55 meters. So we have what? We have the radius, which is equal to 0.55 meters. Okay? Remember, I'm going to remind you this. We had the focal, and then we had the radius, which we were putting C, center. This radius is twice the size of this focal point, or this focal point is half of this radius. Okay? Remember, we had what? We had, if you have a circle like this, okay? If you go from edge to edge, we had diameter, or you can put capital. If you go to the center, we have radius. For focal point, if you go half of the radius, this is going to be the focal point. Careful, okay? These are the three things that you have to know, and it's going to be really clear what we are doing here. Now, radius is equal to 0.55 meters and is placed above the aisle in a store. Determine the image distance and the magnification of a customer lying on the floor, 3.1 meters. So first of all, we have the customer, which is the object, 3.1 meter. And then what is the magnification? Okay, is the, first of all, to find the distance, the image distance, Q is equal to what? And then we have to find the magnification, okay? And we have what? We have the object distance, which is equal to 3.1 meters. Now to find Q, we have this equation, 1 over P plus 1 over Q, which is equal to 1 over F. Then 1 over q is going to be what? 1 over f minus 1 over p, sorry. Then 1 over q is going to be what? Is going to be 1 over, we don't have f. Careful. How do we find f? Let me do that here. How do we find f? Okay, this is really important. Radius was equal to what? Was equal to twice the focal point, the focal length. Then if you divide this by 2, divide this by 2, because we're trying to find f. We need this f. Cancels, cancels. Focal length is equal to radius divided by 2. Radius is equal to what? It is equal to 0.55 meters. Okay? Divide this by 2. You're going to get what? You're going to get 0.275. But is that it? No. Never forget something. Never forget something. What type of image is this? It is convex. So I'm going to put a minus here. Minus 0.275 meters. Careful. So we found the focal length. Minus 0.275. Okay, then let's continue. Minus 1 over p. P is equal to what? We're not going to put minus for p, careful. Object distance is always positive. Okay, so 3.1. Divide all of this, and 1 over q is going to be what? Divide this. You're going to get minus 3.636 minus 0.323. Add all of this together, and you should get 1 over q, which is equal to what? Minus 3.958. Cross multiplicate minus 3.958 q, which is equal to 1. Divide this by minus 958. Divide this by minus 3.958. Cancels, cancels. Q is equal to what? It is equal to minus 0.25 meters. You see, we got minus. Why? Because it's a convex mirror. We found the image distance, which is equal to minus 25 meters. Now, let's find what? Let's find the magnification. Magnification is equal to what in terms of the distance is equal to minus q divided by p. Then we have minus 0.25 divided by p, which is equal to 3.1. Magnification is equal to what? It is equal to 0.081. The image is virtual and it is upright. We don't have the height here, so we don't need to find it. Let's start question 5. Question 5, we have what? Let me erase that. Question 5. Question 5, it says a spherical glass ornament is 6 centimeters in diameter. We have diameter this time, which is equal to 6 centimeters. If an object is placed 10.5 centimeters away from the ornament, okay, where will its image form? So question 5, we have what? We have the diameter, which is equal to 6 centimeters. Then we have the object distance, which is equal to 10.5 centimeters. Where will its image form? So Q is equal to what? What is the magnification? Magnification is equal to what? Okay. Now, is the image virtual or real? The image inverted or upright? First of all, you might see we have diameter. How can we use this diameter in our question? Now, to find Q, we had this equation. 1 over Q is equal to 1 over F minus 1 over P. Do I have P? Yes, P is equal to 10.5. Do I have focal length? No, I don't. Remember, if you have a circle, I'm going to repeat that again so that you understand this better. If you go from the edge to edge, Okay, if you go from edge to edge, you have what? You have diameter. Diameter here is equal to what? It is equal to 10. It is equal to 6. Okay, diameter is equal to 6 centimeters. Now, let's go half of it. Let's go half of it. What are we going to get? Half of it is going to get as radius. So radius is equal to what? It is equal to 3 centimeters. What about the focal length if we go half of it? So we're going to divide this by 2. 3 divided by 2 is going to be 1.5 centimeters. That's it. Okay, so to find the radius, okay, to find the focal length here, we're going to first divide. Okay, now we have diameter. To find the radius, we're going to divide diameter by 2. Then diameter is equal to 6. 6 divided by 2 is going to get 3 centimeters. That is the radius. Then focal length was equal to what? Was equal to radius divided by 2. We have 3 centimeters. Divide them by 2. Then this is going to be 1.5 centimeters. That's it. I found the focal length. But remember, it's what? It's a convex mirror. So minus 1.5 centimeters. Okay? Minus 1.5 centimeters. Now, let's just plug in our numbers. Let me do that here. We have 1 over q, which is equal to 1 over minus 1.5 centimeters, minus what? 1 over, we had the object distance, which is equal to 10.5 centimeters. Now, if you divide this, and if you divide this, we have 1 over q, which is equal to minus 0.6666 minus 0.0952. Add these two together, then you're going to have what? You're going to have minus 0.7618. Cross multiplicate again. Q 7,618 minus q is equal to 1. Then divide both sides by this number. You have minus 0.7618. The same side too. Minus 0.7618. Cancels. Q is going to be equal to what? Q is going to be equal to minus 1.31 centimeters. Okay, that is our Q. You see Q is minus. Why? Because it's a convex mirror. Let's find magnification. Magnification is equal to minus Q divided by P. Then minus 1.31 divided by what? Divided by 10.5, which is the object distance. Magnification is going to be what? 0.125. Is it less than 1? Yes. Then the image is virtual and it is inverted. That is question 5. We have question 6. A candle is 49 centimeters in front of a convex mirror. Okay, so we have what? We have P, which is equal to 49 centimeters. That has a focal length of 35 centimeters. Focal length is equal to what? It is equal to minus 35 centimeters. What are the image distance and magnification? Image is equal to what? The image distance, and magnification is equal to what? Is the image real or virtual? It's virtual. It's a convex mirror. We should get a virtual image. If you didn't, then there's something wrong with the question or with the calculation. Now, question 6, we have what? Let's find the image distance. 1 over q is equal to what? Is equal to 1 over f minus 1 over p. Okay, we're trying to find what first? We're trying to find q. 1 over q is equal to what? Is equal to minus 35 minus p, which is equal to what? 49 centimeters. Then, if we divide this and divide this, 1 over q is equal to what? Minus 0.0285 minus minus 0.0204. Okay, 1 over q is going to be equal to what? Is going to be equal to minus 0.489. Then cross multiplicate. Q is going to be equal to what? Q is going to be equal, if you calculate this, Q is going to be equal to minus 20 centimeters. What is the magnification? Magnification is going to be minus Q divided by P minus 20 divided by P, which is equal to 49. Then magnification is equal to what? It is equal to 0.41. The image is, like the magnification is less than 1, so the image is virtual and it is upright. Okay, that's it. We have solved all the questions. The next lesson, we're going to briefly talk about spherical aberration, and then we're going to solve section review. And we will be done with this chapter. See you in the next video.